Today we're going to talk about carbohydrates as one of the big four macromolecules in our biochemistry unit. Let's take a look first at this word, carbohydrate. First starts out the carbo part. Might make you think of carbon, and rightfully so. So the element carbon, big part of carbohydrates, and then you also might think to hydrate something would mean to get water. And again, you're on the right track. It's not perfect, but you're certainly on the right track when it comes to what a carbohydrate is. Carbon and water is a piece of the puzzle, and we'll see how so in just a little bit. The other piece of the puzzle is the fact that you think of carbohydrates oftentimes as a fuel source. You eat carbs for energy sort of thing, and that is true much of the time, but certainly not all of the time. Cells use carbohydrates as a form of energy, but also they could use it as a basis for some structural building materials, and we'll look at a couple examples as we go through this today. Some general characteristics of carbs. So when you talk about carbohydrates, you probably think of words that end in "ose." Sucrose, glucose, fructose, galactose, maltose, lactose. All these "ose" words, cellulose. There are a few that we're going to talk about that don't end in "ose" that still do fall into the carbohydrate category, but very commonly if you hear a word ending in "ose, it is a carbohydrate. Then the other piece of the puzzle is this ratio that we're going to take a look at. And this does kind of follow suit with the word carbohydrate. So you've got carbon, hydrogen, and oxygen, and it's formed in a 1:2:1 ratio, where it's gotta scroll there, where it's 1 carbon to 2 hydrogens to 1 oxygen. And so there's this formula, 1 carbon to 2 hydrogens to 1 oxygen, but also this factor of N, where N is greater than 2. So if you're able to follow along at home, N's smallest number that it could possibly be would be, let's see if I can get this better. Smallest number that it could be would be that's a number 3. So N could be, there we go, 3. If that were the case, then you could have C3H6, because it would multiply the 2 H's times the 3 on the outside, and then O3. So our smallest carbohydrate that we could have would be C3H6O3. A classic example takes it so that N would be 6, C6H12O6, and we'll talk about some of those as well. Probably you are familiar with that as glucose. How about a fun slide real quick to get us going here? 8 things that I just absolutely hate. I hate people who point at their wrist while asking for the time. Like, hey, do you know what time it is? And they're sitting there pointing at their wrist. I know where my watch is, pal. Where the heck is yours? Next one. People who are willing to get off their butt to search the entire room for the TV remote because they refuse to walk to the TV and change the channel manually. I've actually come to think that this maybe shouldn't be something I hate anymore, because some of the new devices, DirecTV, cable boxes, things like that, they don't even appear to have changing channel options on the box. And if you change the channel on the actual TV itself, it takes you off of the cable. So maybe I have to take that one back. I hate when people say, it's always the last place you look. Well, of course it's the last place you look. Why would you keep looking after you've already found it? So last place you looked, here it is, found it. I hate when people say while watching a film, did you see that? No, I paid $9 to come to the cinema and stare at the floor. Of course I saw it. I hate people who ask, can I ask you a question? Didn't really give me a chance, did you there, sunshine? When something is new and improved, which one is it? If it's new, then there has never been anything before it. And if it's an improvement, then there must have been something before it, and therefore couldn't be new. I hate when people say, life is short. Life is the longest thing anyone ever does. What can you do that's longer? Of course. When you're waiting for the bus and someone asks, has the bus come yet? I hate that, because if the bus came, would I still be standing here? Back to some carbs. Monosaccharides. The word monosaccharide, again, has some meaning, just like carbohydrate had some meaning. The word monosaccharide, mono means one or single, and saccharide The prefix, or in this case, the root of the word saccharine refers to sugar. And so anytime you see something that is saccharine, saccharide, saccharin, they're talking about sugars. Usually monosaccharides, one unit of sugar, is 3 to 7 carbs in size. And here would be the smallest one. We talked about the C3H6O3 would be the smallest. It is oftentimes called a triose sugar. So triose refers to 3 carbon sugar. And you can also see on this that there is an aldehyde group up here at one end of this 3 carbon sugar. And if you recall from some of our model building stuff and talk about isomers, here is that triose sugar of glyceraldehyde. They even put the aldehyde name into it. Some other common monosaccharides, the pentoses, C5H5O5. Pent, again, refers to 5, and in this case, 5 carbon sugar. Pentoses that you may be familiar with, ribose and deoxyribose, commonly found in DNA and RNA, and those of you that have taken BBG are probably quite familiar with these. They sometimes are found in this chain form. We'll talk a little bit about how they're sometimes also gone into the ring form. But if you look at the very top of this chain, they always start counting with where the aldehyde group is. And in this case, that's the number 1 carbon all the way down to here, where we have the number 5 carbon. So this is the ribose sugar. Then there are the hexoses. Hex refers to 6, and so the hexoses are the 6 carbon sugars. There are a couple different kinds of hexoses that we'll become familiar with. Over here on the right, there are 2 different kinds of hexoses. They are considered to be isomers of each other because they are both C6H12O6. And you can see there is very little difference in the actual structure other than right here, where we have the difference between that hydroxyl on the number 1, 2, 3, 4, 5, 6. So on the number 4 carbon, the placement of that hydroxyl group on that one is what determines is it going to be glucose or galactose. So structurally quite similar, but just ever so slightly different. Glucose as a hexose is by far the most common energy source for cells, and it is also one of the most abundant hexoses and one of the most abundant carbohydrates out there. Fructose and, as mentioned already, galactose are isomers of the hexose glucose, and are all structurally quite similar. We'll look at glucose a little bit more in the future and how it bonds up to fructose to see how there are some slight differences in those 2 hexoses.